This UCSD TV program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest programs.
We are the paradoxical ape, bipedal, naked, large-brained, long the master of fire, tools, and language, but still trying to understand ourselves, aware that death is inevitable, yet filled with optimism. We grow up slowly. We hand down knowledge. We empathize and deceive. We shape the future from our shared understanding of the past. Carta brings together experts from diverse disciplines to exchange insights on who we are and how we got here. An exploration made possible by the generosity of humans like you.
We heard from Jeff Severinghaus about the greenhouse effect of carbon dioxide on Venus. And that brought me fond memories when 45 years ago, I got started in this field by taking the quantum mechanics of the carbon dioxide molecule and trying to figure out how it maintains the climate of Venus and Mars. So how did I go from quantum mechanics to talk about a topic which is totally foreign to me, in pursuit of the common good? So I have to walk you through how my science led me into the villages of India and Kenya and finally found myself face to face with Pope Francis last year. And that's what gave me this idea of the pursuit of the common good. So let me start with a 30-second lesson on climate and climate change. The fundamental energy source for the planet is sunlight, incident solar energy. Not all of that is absorbed by the planet. The intervening clouds and ice sheets and surface bounces some of this back. So about 70% is absorbed by the planet. That heats the planet, and it gives off this energy in the infrared wavelengths. We call it heat radiation, infrared radiation. But not all of that can escape to space. The intervening atmosphere, particularly water vapor and carbon dioxide, acts like a blanket and traps this heat. In fact, the blanket is a good analog, if not a metaphor, that the blanket keeps you warm on a cold winter night, not because it gives off any heat, it traps your body heat. That's exactly how these gases trap the planet's infrared heat, which is what we call by greenhouse effect. Nature gave us a thick blanket, and later I'll tell you how thick that blanket is. So without that, the planet would be so frozen beyond anything we have seen in the ice ages, which Jeff showed us. So now, what we've been doing is adding to that blanket, making that blanket thicker. So the first of this, we heard about it, carbon dioxide, and that was worked out more than 100 years ago by Svante Arrhenius, the famous chemist. He did some of the most definitive calculations in 1896. I know this paper very well because the Swedish Academy at the 100th anniversary invited me to write a detailed critique of this. So for nearly 80 years after the publication of this paper, we thought carbon dioxide was the only molecule causing the greenhouse effect. In fact, many talks today focus on the CO2. After I finished graduate school, I stumbled on this totally shocking and surprising discovery given for myself that we were releasing other compounds, particularly chlorofluorocarbons, CFCs, and my work showed taking again, starting from the quantum mechanics of the CFC molecule, addition of one molecule of CFC has the same greenhouse effect as adding 10 to 15,000 molecules of carbon dioxide. This is, mind you, purely synthetic gas used as refrigerants and propellants, but the CFCs were also involved in damaging the ozone layer. So the Montreal Protocol in the 1980s phased out, banned the use of chemicals after the discovery of the Antarctic ozone hole. Just in the last 5 years, my work was recognized, and The Economist called the Montreal Protocol as the best climate mitigation strategy. Because my work had shown, if we had not banned CFCs, the CFC alone would have caused a 0.5 degree warming so far. Okay? So now, let me go to the real gorilla on the table, which is carbon dioxide. You know, the theory is being attacked. So the key thing is, remember, any theory is judged by its predictions. So in 1980, I teamed up with the famous meteorologist Roland Madden. We took the observed climate fluctuations, so-called noise, and said, when will we detect the signal, carbon dioxide warming? So we predicted, if the theories, Arrhenius' theory was right, we should see the warming by year 2000. As you have seen, it's after in the 1990 to 2000 period where I've shown the shade, where the warming rose above the background noise. In fact, 1,000 scientists said, finally, we are seeing the human-induced warming. So there, a forecast came out to be okay. So for the last 30, 35 years, I've used varieties of instruments. The one I show on the left-hand side is the satellite, which I helped design that with 3 other scientists at NASA. We were looking at the regulation of the heat flow in and out of the planet by the atmosphere. More recently, we developed this unmanned aircraft to look at how that heating from man-made pollutants is really warming the planet. So let me walk you through. What we did was using these to track down each of the prediction by models and theories and see, are they coming to true? So the first thing we went after is what's called the water vapor feedback. Remember, I think Jeff showed, several talked about the warmer atmosphere holds more moisture. But water vapor is the most powerful greenhouse gas. So we determined the greenhouse effect directly simply by, we have estimated the infrared radiation coming from the ocean. It's basically given by the Planck's black-body law. Then we were measuring the heat escaping to the top of the atmosphere and difference the two to look at the thickness of this blanket. What you see here in the tropics is where the blanket is at its thickest. Our unit for measuring the thickness is watts of energy trapped. So why is so much greenhouse effect happening in the tropics? It's warm and humid, water vapor greenhouse effect. But we were not satisfied with that. We wanted to see, as the planet warms, would the greenhouse water vapor increase? So on the right-hand side, you see, I'm not going to go through step by step. Every year, the planet does a spectacular experiment. It's the entire planet, when you average, it's hottest during August and coldest during February. Remember, August is winter in the southern hemisphere. So when the temperature increases, we found with the satellite, the greenhouse effect increased exactly as predicted by models. And then you ask, why did that increase? That's the last bottom panel. It's because the water vapor increased as the planet temperature increased. So why is the water vapor increasing? It's basic thermodynamics. The vapor pressure of moisture above a body of water increases exponentially with temperature. So here it is. Arrhenius was the first to suggest it. The next was another theory which was done by a Russian climatologist, so-called sea ice albedo. Charlie Kennan already showed that. This took me 30 years to start from the launch of the satellite to come to this. It was one of my graduate students' thesis work. So as the Arctic sea ice retreated, what the climatologists said is, the ice absorbs only 50% of the sunlight. It bounces everything back. That's why it's white. When you melt the ice away, you get this sudden tipping point. You see the dark ocean. And we documented that exactly how much energy, and that energy increase, although it's in a tiny part of the planet, Arctic, was so large that it was equivalent to 1/4 of the greenhouse effect of CO2 increase. Okay? Again, this was suggested, but the magnitude of the feedback is much larger than what the models were using. The last one I want to mention to you, one of the key things we are after is the warmer planet going to be more cloudy? Why is that an important question? Clouds are one of the most powerful regulators of sunlight. The clouds are white because it's reflecting 50 to 70%. In our planet, both in the northern polar region, southern polar region, this massive extratropical cloud system. Remember, that's what you see when you fly across into the Pacific Atlantic, thick white. They are the refrigerants for the planet. What we are finding is, think of them as two white umbrellas. They are shrinking, letting in more sunlight into the tropical ocean, again an amplification. So when we put all of these together, remember I forecast in 1980, boldened by the success of that, we made two forecasts 7 years ago that we have already dumped enough gases to keep the planet by 2.5 degrees. We have only seen about 1/3 of it. The other thing, which is what made me go after the pursuit of the common good, said we are going to hit this 2 degrees, not what people are saying 100 years from now, around the corner, 30 to 40 years from now. Okay? So the so-called 2 degrees is facing us already. So how do we slow down the warming? Of course, most of the studies talk about cutting down CO2, which I agree with. So we came with a number to reduce the long-term warming. You've got to stabilize the CO2 below 440 ppm. CO2 is already at 400. So to limit to 440, we can't emit more than 1,000 billion tons. That looks large, but every year we are emitting 40 billion tons. So we have only 25 years left, okay? But that's not going to help the near-term warming because CO2 is like a supertanker. Its lifetime is centuries to 1,000 years. It's not going to respond quick. So remember my work on the CFCs, that's put as HC, halocarbons. That's a family of chemicals. And after that work in 1975, we came with numerous other pollutants. Ozone, it's called smog. Methane, we heard about it. The other is black carbon. It is soot, the dark stuff which comes from diesel. It's not a greenhouse gas. It's a particle that absorbs sunlight. Much of my work with UAVs was to track that. But we have technologies to cut them down. And their lifetime is few weeks to a decade. If you eliminate black carbon from diesel, their warming effect is gone 2 weeks from now. So we said if you cut these pollutants with existing technologies, we can cut down the rate of warming in the next 30 years by nearly 50%. So you need a two-pronged strategy. So now let's look at who is going to do which. By the way, this idea of the CCAC, the short-lived climate pollutants, I wrote a paper of this for policymakers with a political scientist at UCSD that was led by Hillary Clinton. And she formed a coalition 3 years ago. Now there are 40 nations are working to cut down the short-lived pollutants. So now, let's look at the human side of the problem. For reasons I'm not going to get into, I spent, took my sabbatical and spent with my wife living in villages in India for 3 months. We also do work in Kenya. And every week or so, the life in the village was so oppressive, I would escape to the nearest city for a cold glass of beer. I have a movie I'll show if there is time. That's when I discovered my God, there are two worlds in this planet. The first is inhabited by the top 1 billion, with obviously seemingly unlimited access to fossil fuels. The other world is inhabited by the bottom 3 billion, lack of access to the fossil fuels, even for cooking. They still burn firewood and cow dung. I was having my meals in this woman's house in the foothills of Himalayas. So the top 1 billion consume 50% of the energy, are responsible for something like 50 to 70% of the greenhouse gas emissions. So while population is a problem, as Dr. Hadley said, the other big gorilla is unsustainable consumption by a small part of the world's population, okay? Particularly climate change. So in terms of cutting CO2, the buzzword is decarbonization. So that takes about, it's been estimated, about $1 trillion per year. That's about $1,000 per person for the top 1 billion. And our fossil fuel subsidy is about $450 billion. So you take it out, it's basically a $500 problem we are arguing about. And then the second thing is, the worst consequences of climate change is going to be experienced by the bottom 3 billion. This woman represents about 600 million women around the world who are in subsistence farming, 1 or 2 to 5 acres. A drought like what hit California, extending for 3-4 years, would wipe them out. They would become homeless, go to slums in cities, et cetera, et cetera. So the question is, we have to give them energy access. And that has also been costed out. It's about $250 billion. So if you divide it amongst the top 1 billion, it's a $250 problem. So the question we have to ask is, why should I living here? I'm, of course, part of the top 1 billion. I'm almost on the top of the top 1 billion if you bring all my travels. So why should I give $250 to this woman sitting in Himalayas? If I don't do that, she climbs on the fossil fuel ladder. Her consumption, fossil fuel, will go up by 30%. Another 12, 13 billion. So purely selfish reasons, we want to provide energy access, but we know if you throw 250 billion, it's not going to reach them, right? So we started a project called Surya, where we developed improved cook stoves to cut down the emission. In the left curve, my daughter developed cell phone technologies to measure these emissions. My instruments were all way too expensive. But this cook stove is about $70 a person. That's about 5 weeks of her paycheck, okay? So we said, she's cutting down climate by cutting down the black carbon emissions and CO2 emissions. She's saving about 5 tons a year. So if I give the minimum carbon credit to her, which is about $15, she'll get the stove paid off, and she'll be making money next 2-3 years. But how do you know she's going to use it, right? That's the biggest problem in compliance. So I went to my daughter again, asked her to do something useful. She's a wireless technology genius. So she came up with the simple temperature sensor, which hits as soon as she starts the stove, the data comes to her lab. She's at Los Angeles. She shifts to my lab. We convert it to carbon credits. UCSD created the first climate mitigation fund. And we have demonstrated it in 5,000 homes. In fact, this work was started first by donation from Qualcomm, Charlie Kennel, and a billionaire in San Francisco got it started. So next week, this methodology has been accepted by United Nations. I'll be there next in a summit. They're going to release it as one way to provide energy access. So let me go on. So I've now taken my quantum mechanics to villages. So why did I meet the Pope? Clearly, after we heard from the last speaker and the previous speaker, I decided, by the way, I'm never going to follow Naomi Oreskes. I was so mesmerized what she was saying, I forgot what I was going to say. So we teamed up. I belong to the Pope's Academy of Science with economists, Nobel laureates, in biology, physics, chemistry. In fact, Charlie and Naomi attended that summit. And we discussed to see this whole issue of sustainability. And at the end of it, we were asked to brief to the Pope. And I've been in this academy for the last, every time we meet Pope, like Pope John Paul and Pope Benedict, it's always in the most ornate room in the Vatican. This Pope met us in the parking lot, right here, you say. That's why he's called People's Pope. So we briefed. What was remarkable about this group, at the end of it, 3 days of intense talks, we didn't talk about technology, we didn't talk about this. What we said was, the main way to solve this problem is to change our attitude towards nature and towards each other. And remember, by leaving 3 billion behind, they're going to suffer the consequences of our fuel consumption. And then from the previous speaker we heard, we're going to read generations of yet unborn suffering our unsustainable consumption. So it's a moral issue. So what we are saying is that religious leaders should take hold of this. And 2 weeks ago, Pope Francis, because of this previous meeting, assembled religious leaders from Islam, Hindu, Jewish, all the religions were represented, and they all signed a declaration. And anyway, so let me just come to the last point. I joined this infamous group, Planetary Boundaries Group. So we published this year this planetary boundary that is, there is a safe ecosystem, that's the inner circle, and then you exceed the outer circle, you go to the danger zone. And so there were 8 components we identified. I was the only climate scientist there. And climate change, and then the atmospheric aerosol loading is there. 2 of the components, we already exceeded the boundaries. Dr. Hadley's talk beautifully showed that, species extinction. It turns out our extinction rate is 10 to 100 times larger than when we compared to extinction rates before humans really started colonizing the planet. The other major is nitrogen. Fertilizers. We have anoxic zones in the ocean, dead, because pollutant effluents from the ocean. So climate change, there are denialists because of political and economic reasons. But our chairman also said we are also denialists. It is coded into our genes. So no matter how, if we don't do much about it, I want to conclude with my prediction that you see that the red zone, the climate was still in the yellow zone. We would exceed that by 2050, 2 degrees. So the Anthropocene, which is coined by my good friend Paul Crutzen, will reach adolescence by 2050. I'm thinking there the teenage is the most dangerous age in a human being's evolution. Right? So we'll reach 2-degree world, but I predict when we reach 2 degrees, the changes will be so huge, just physically and thermodynamically. The water vapor alone would be 15% more, fueling the storms, fueling droughts, fueling floods. So we would change our attitude towards nature. We will decarbonize the economy, but I'm saying it's a $450 problem amongst the top 1 billion. It's safe to assume all of us here belong to that prestigious club. And then we need to provide clean energy for the bottom 3 billion. Okay? Thank you very much.